Yeah, that's me. Thank you. Welcome. It's really an honor to be here this morning. This is my first time to Poland, to Krakow, and I've heard amazing stories about Krakow. I hope I will see some of the beauties this city has to offer in the evening. But this day is full of knowledge, full of learning, and today we start with microservices. So raise your hands if you are doing microservices in your company right now. That's great, a lot of people. Raise your hands if you have more than 20 services. Okay, a few. And regardless of using microservices or not, are you using Docker in production? That's great. Some of the hands dropped, but that's perfect. So I hope some of you have a knowledge of microservices, but today I will try to challenge what you already know about microservices and try to set another baseline for growth and for the next generation of microservices. So let's start with the standard boring stuff. I'm Armagan Amcalar. I come from Germany, from Berlin. I'm working at UNU GmbH as the head of software engineering, and we are developing electric scooters for the future of mobility. And I'm also pretty much active in the open source community, in other communities, and I lead a volunteer organization called Lonja, which is a software craftsmanship school for women, because it's apparent like most of you are men, which is unequal, and we need to change that. Yeah, I have quite a lot of libraries and projects on GitHub that range from front-end libraries to microservices, to brain signal processing, to guitar effects, and a lot more. So I encourage you to check them out. Okay, what are we going to talk about today? We will have a quick overview of what microservices are and what they should be, the best practices of microservices. And then we will focus on an example e-commerce application, and I will try to explain the best practices with an e-commerce application. Raise your hands if you have ever developed an e-commerce application, like a website that sells something online. Yeah, the rest of you are really lucky. I didn't really find that particularly entertaining to do an e-commerce application, but it's very common. A lot of people do it, so that's also a good example for microservices, and we will focus on such an example. And then we will look at the properties of a modern microservices approach or the next generation of microservices with the e-commerce app. I will then show a quick intro to a Node.js microservice application server client and how the code actually works. I will talk about Docker, how Docker works, and how it actually helps microservices, and finally finish with another demo. So raise your hands if you are doing Node.js. That's great. That's a lot of people. So I actually prepared a demo for you today, which didn't quite work out when we initially tried. Maybe we can try during the talk. But the idea is the next generation of microservices should be zero configuration. And today I'm going to talk about what it means and how we actually realize it with Node.js and Node.js microservices. Anybody doing Node.js microservices? So combining the two? What are you using? Express, Seneca? Express? So you're doing HTTP services? Yeah. Okay, let's start with the definition of what is not a microservice. Because, you know, this is a hype. This is a hype that everybody is talking about since years, and there are a lot of information. You know, suddenly Nginx became a tool for microservices, right? No, it's a web server. It's as simple as that. It's a web server. It's not a tool for microservices. So there is a lot of bogus about this topic. So I'd like to clear what microservices are not first. If you're using queues, if you have queue consumers, like for settlement, payment settlement, for notifications, for emails, for asynchronous jobs that have nothing to do with responding to a client, then you're not doing microservices. Even if you have 50 of those small queue consumers, even if they are really tiny and you know they have a single responsibility, unfortunately they are not microservices. it could be notifications, logging, reconciliation, emailing again, or sending invoices to a customer after a purchase. It's not a microservice architecture. Even if you're running multiple applications on a single machine that communicate over HTTP, this still doesn't make it a microservices application. Unfortunately, it's really different from this. So the definition is, if you're breaking down the fulfillment of a single client request into multiple programs that live in their own memory space, then we can call it a microservices architecture. So, when you purchase something online, there's a single button called buy or purchase, right? Or order. And that basically does the magic. It sends your credit card details, checks the inventory, and checks the catalog if the item is still available, and then lets the delivery guys know that there's a delivery, and you also get an invoice as a result. So all of this actually happens in a single click. Now, if you are breaking down this whole response into multiple servers, multiple services, then that's called a microservices application. So the order service should check for the order availability, or the inventory service should check for the inventory availability, and it is in every position to affect the client's response. If the inventory is empty, you cannot make a purchase. So that client's click is actually tied to multiple programs who have the authority to reject the call or to affect the call, to put some information in it, like delivery information. Now, again, if you are creating a JSON as a response by gathering it from other programs that are running in your ecosystem, then you can call it a microservices architecture. So, anybody familiar with domain-driven design? Few of you, that's nice. It's a great book about software architecture and how you should structure enterprise software. It's actually quite old, so maybe even, I'm exaggerating a little bit, but maybe even older than some of the audience here. But it's still a really, really good book that shines light on how we should do software architecture. And apparently, it maps 100% with microservices. So if you're following domain-driven design, if you have bounded contexts, if you have clear interfaces between the domains, then your application is really suited to microservices. And you can break your application down into individual domains at worst. At best, every model would have its own microservice. But still, if you're applying the best practices of domain-driven design, then you're already far ahead in this game. Now, the rest is actually the topic of another talk on its own, but very briefly, microservices come with a lot of change. It's not only a change about software architecture, but it's only a change about your team structure, because maybe some of you know there is something called the Conway's Law. Every organization produces a software that is the exact replica of their organization scheme. So microservices demand distributed teams that are autonomous in their decisions, in their technology, which means a lot of change for the companies, which means there is no micromanagement anymore, and you have to find other intelligent ways to manage your engineers, because it comes with a lot of autonomy and automation. So testing, configuration, everything that is related to infrastructure management, like monitoring, deployment, they should be automated all the way down. So it's a fully automated system that is also synonymous with DevOps. Anybody doing DevOps? That's great. You should. Because it's 2017 and nobody should be able to, nobody should manually deploy any application to your server farm. You shouldn't manually configure anything. You shouldn't use SSH. If you're using SSH to log into your servers other than your database servers, then you may need to review your approach. And the last one is favoring cattle over pets. Anybody heard of this before? 1, 2, 3, maybe? That's great. So it's a great term. Pets are animals that you call by name, that you own, that are part of the family, right? So you have a dog, it has a name, and you call that dog by its name. It eats with you, it sleeps with you. That's part of the family, so you care for it. And obviously, you don't want it to die. You love it, and you expect love in return, and there's nothing else. But cattle is a little bit different, like a cattle of sheep or cow. They're mostly for industrial purposes. You use their milk, you use their fur. You don't really sleep with them. You don't really have an intimate connection with your cattle. You don't even name them. They don't even have names. And unfortunately, this is a little bit of a stretch here, but unfortunately, if they die, you don't really mind. You just replace them with another one, because all you care is the production or output that you get from those animals. So this is used to define the server environment, the cloud environment that you should be running in. You shouldn't be caring about your servers individually. Any system administrators here? Sysadmins? Yeah. Tell me if you have given funny names to your servers in the past. Yeah, not anymore. But that was a common practice, like even 5 years ago, maybe 10 years ago. System administrators were really proud of the names that they give to their servers. They were really caring for them. But the times have changed, so now it's all over. It's all automated. You just know the number of servers you have. You don't even know the IP addresses, the host names, nothing. Actually, you don't even know in which data center they are. So this is favoring cattle over pets, because all you're interested in the CPU power and the RAM that they provide you to run your services in an automated fashion. So let's look at the example e-commerce application. This picture may be familiar to some of you. We have an API gateway that acts as a load balancer in the application, which, serves your host name. On the front end, we have two interfaces, an admin interface, so that we can check the inventory, the catalog, the users, the user registry, and an end user interface where people, clients, customers can go and check the catalog and make purchases, make orders, and hopefully make us rich. So this is an example microservices app. Although these services are not really micro, it's good to see the separation of concerns. So we have on the back end a purchase service, a payment service, a user service, and a product service. The first thing that you should notice here is all of them have their own databases. So this idea stems from the autonomy and the individual behavior of microservices. In order to ensure a clear separation of APIs, a clear definition of APIs or interfaces, you have to separate your data. So beforehand, you may have had classes that reference each other over across domains. When you want to make a purchase, you include user model and do a fetch, so get user details from the database itself. Or maybe you can affect the database in another area of responsibility. That is no more. So these services own the domains, and if you want to get a user, you ask the user service. You cannot approach the user database directly. It won't work. Obviously, this comes with a lot of problems, like data replication. So probably the purchase service will keep copies of users in its own database for fast access, for cache. So data consistency may be a problem here, but that is something you need to resolve in order to achieve a good microservice architecture. So let's move on. The connections here, you see the API gateway is connected to all of the three services. To make a purchase, you go to the purchase service. To fetch the user, you go to the user service. To fetch the user histories, you still go to the user service, but to fetch that user's purchases, user service actually goes to the purchase service and says, hey, I want the history for this user, so please give it to me so that I will get back to the client, to the end user, and display its list of purchases. And you see the product service is actually independent of all of these. This is really important in the coming scenario. So the first rule of microservices is auto-discovery. Whenever there's a new system, whenever there's a new service in the system, all the other services should automatically discover it, which means, here we have the log service. Beforehand, there was none, so the services actually didn't know anything about the log service. So it's just a new kid on the block. And whenever it's online, all the other services should discover it. Hey, there's a new service available in my ecosystem. So I was waiting for it, actually. So why don't I just go and connect to it and discover it? And maybe I will send my logs to it if I'm programmed to do so. But the idea is, whenever there's a new service, you shouldn't be redeploying your whole application. You shouldn't be configuring your previous services to give them the IP address of the new service so that they can communicate. It should be handled automatically for you. And when you have auto discovery, the next step is zero configuration. We live in the world of cloud systems and huge scale. So probably one instance of one service will not cut it for you. And you'd better have multiple copies of each services. Let's say the purchase service here in the example. I just copied the purchase service, so I have 3 copies right now, which means it runs on maybe 2 more servers, or maybe the same server, I don't know. But I should. That is, like, if I need to achieve horizontal scalability or high availability, I should care for that. But the idea is the rest of the system should be unaffected by this change. They shouldn't care how many instances of purchase service you run, and they shouldn't care, again, about the configuration of the IP addresses of the ports the applications are running. So no more listening to port 3000, no more listening to port 80 on the services. It should be automatically configured for you, and you shouldn't care. And in this case, when you want the history of a user, it should communicate to the purchase service, and it shouldn't care which one of the purchase services it communicates to. The history could be delivered by any of these, any 3 of these, or maybe partially from all 3. The next one is, if we have zero configuration, why don't we just create multiple copies of our application so that we make it highly redundant? Like, just put one in every availability zone in AWS or in any other cloud provider, so that you run multiple copies. They're all configured automatically, so that whenever one fails, the others will still continue to serve you. Although you may have some load on your services, at least there is, due to redundancy, there is no loss of operation. And the other idea is, that stems from this, is fault tolerance. So what happens if all the payment services are down? Will your application fail? This is a common scenario with payment providers. If you're using Stripe, PayPal, Adyen, I don't know, any other payment provider, they sometimes have their own problems and their own loads. So your application actually stacks up the client requests to make a payment, but they may go down. And eventually, they will bring your application down, because you have a set number of threads listening on your client requests, and they're all blocked, waiting a response from the payment provider. How do you actually solve this? If the payment service is down, it will bring all your application down. If you're doing a monolith application, nobody will be able to visit your website. Nobody will be able to browse the catalog. Like, they don't want to do a purchase. They just want to see what items you have. But they won't be able to do that if you lose one of your services. That service could also be lost based on its own load. It doesn't have to depend on another external party. But the idea is, remember when I told you the product service is unaware of any payments, the product service shouldn't be affected by this, which means people should be able to browse your website and its catalog, but when it comes to payment, they won't be able to make a payment. Maybe they will even save their order, save their basket, but the payment step will be done afterwards. But your website, your application will be up and running. So any modern microservices infrastructure application should be fault tolerant. It should allow for losses, partial losses of these services. And the rest of your system should be unaffected. Of course, we will not just be okay with losing some services. Our orchestration management, our system, should be self-healing. So when you lose some of the services, like the payment service, you actually should create new instances, new copies automatically, like without even manual intervention from your DevOps team, from your infrastructure team. It should be automatically created in your cloud somewhere, because it's zero configuration. Everything just resumes normal operation, and people can start making payments again. And all this time, I didn't touch the purchase service. I didn't touch the user service. I didn't restart them. I didn't redeploy them. So these are the 5 rules of microservices. Now, here's a simple example in Node.js. I hope you can all see the code, but I will try to go through it line by line because it's very simple. This talk is about a library called Code. Disclaimer, I wrote it 5 years ago. It was a state-funded effort, and it's now worldwide open source on GitHub for 5 years. And a lot of companies are already using it, including every company that I worked in, of course. So this is a library for Node.js that makes all of these rules available to you out of the box without any third-party library or tool. It doesn't use Redis, it doesn't use console. It's just a Node.js library, and it relies on a router. So the idea is you require code, obviously, as a library in the first line, and maybe you have some models. Anybody working with Mongoose? A few people. Databases in Node.js? Raise your hands. Okay. So if you have a database in Node.js, you probably have a model, a data model, and that's what you require to make some operations on it. So the code block on the top is a client, and the code block on the bottom is actually a server, a data server. And sorry, the other way around. The code block on the top is the server, it's the responder, and the code block on the bottom is actually an express application, which you may be accustomed to. All it does is forwarding the incoming requests to our code ecosystem. So whenever there's a get users /ID /123 whatever, it sends this to the requester with the ID, and then just gets the reply and sends it back to the browser or the client, whatever. And on the back end, our server is just responding with a model call, model users.get request.id. Now, this is all you need to run microservices wherever you are in the world. There is zero configuration involved. If you actually deploy this with Docker or Docker Cloud or Kubernetes, that's even better, because then you can scale across clouds. Like some of your services could be in AWS, some of your services could be in DigitalOcean or Google Cloud Platform, and you wouldn't care. There are no ports here, no IPs to listen, no host name, no configuration, and you just run this in 2 different machines. As long as they share a common network, an overlay network, this thing will work. And that overlay network is something your system administrators can give you, or even better, use a cloud platform, please. And there are a lot of tools for that. Docker Cloud, Kubernetes, Docker Swarm all give you overlay networks. So you basically can use it pretty much out of the box. Again, this is like a normal JavaScript application, as if it's running in a single thread. Like, we don't even listen to a port. This is crazy. So this is code. The library is available, as I said, on GitHub. And to recap, it has zero dependency. So you don't have to learn another tool in order to be able to use microservices. This is the thing I hate most about the current technology space. Everybody's trying to sell you their products, which you have to download and set up, and then you have to deal with making them highly available and their replication and stuff. If you're using Redis, if you're using RabbitMQ, they all have their own issues. So the idea was, can we actually do without any of these? Can we actually achieve microservices without any dependency? And the result is yes, we can. So again, zero configuration. It's decentralized. This is, again, maybe a little bit different than the other tools. So there are no central nodes. There are no manager nodes to keep track of all the others. This is actually called a mesh network architecture. And in fact, I admit, Code was a library 5 years ago. There was no talk about microservices, and Code was a library for distributed applications. So we didn't know anything about microservices, but the idea was to do distributed applications. And the best way to do distributed applications is when it's really distributed, when it's not centralized. So that's the idea in Code. It is auto-discovery. It has fault tolerance. It doesn't actually lose any service when the payment service is down. It just keeps the requests in memory, and whenever a new one is up, it flushes all those requests. Hopefully you are running this automatically, which means even if your payment service is down, in a matter of seconds, a new one will be up, so you won't lose any requests at all. It's scalable, horizontal scalable, because it's zero-conf. You can scale it to any machine, any number of machines you like. I scaled it up to 100 machines, and it worked, so that's kind of good. It's also performed. If you have a single machine, it can process, 500,000 messages per second. And it has a very nice human API. It's actually very simple to use. If you have ever used event emitters in Node.js, if you know what .on means and how to handle an event, you can pretty much use this. All right, so enough talking. I will show you some demo. Hopefully it will work. Okay. Maybe we can, again, look a little bit into the code. So I'm requiring code here. I have a contact model that is interfacing my database. I have a responder on the server, and I have a requester on the client. And whenever there's a message, like any message comes in, I'm just logging it. And I support 3 APIs, find all, add, and get. Obviously, this is very, very simple logic. Like, it's not the point of this demo. The business logic, the application logic is horrible, no authentication, no nothing, but it demonstrates how it works. And on the other side, I have a client which sends a GET request for the contact with ID 1. So this is like a contacts application. So I start the server, and it says, hello, I'm contact service, and I'm listening to port 8000. Okay, that's fine, I didn't give it. It just found any available open port on the machine. And then I have a client, and there you have the response. I was logging all the requests, type get, and the response. Obviously, this is not very magical when it runs on my machine, because in the end it's a local machine, although I didn't do any configuration at all. So I actually tried with one of you beforehand to do a live demo. In some conferences I do that, so people can actually write their own services, their own clients, and it connects to my machine and I respond to them. But unfortunately it didn't work here. Probably the router configuration, the Wi-Fi configuration blocks broadcast messages, IP broadcast messages. So it is the mechanism this thing relies on, broadcast or multicast. So the discovery part will not work with you. But actually, anybody attending the workshop in the afternoon? The microservices workshop? Nobody? All right. So we will do a demo there of how this works, because obviously I have my own router. Anyway, so let's go to the client. Let's do another call here. Another name. And I restart this, and you see there's a new record. Now, I will go back and do the find all call. Okay. Let's see that it works. All right. It fetched the 2 records. You see here on the left, the server is actually discovering the client, and the client obviously discovered the service. And you get nice offline and online messages, so you can actually do a lot more logic on your end. All right, let's turn off the server and run the client. So this thing still made that request. It wants to get the list of people. Oops. Then I bring it on, I bring on the server, and basically we have the response. So even if there were no servers, this thing didn't lose the request. This is basically how you achieve fault tolerance. And obviously you can create another client. So they will still discover each other and will still work. And you can create another server. Let's restart this. Yeah, the one on the bottom replied this time. Here's the find all call. Let's try it again. The one on the top replied. Because this is round robin load balancing out of the box available to you. Now, okay, how much time do we have? Like 20 minutes. Great. I need some assistance with electricity. I'm running out of battery. That is crazy. Could anybody help me with the organization? Hello. Do we have electricity here? I need to plug in my charger. Oh, there it is. Okay, could you please? Guess it will come back. Yes, we're back. Sorry for the inconvenience and trouble. But this is mostly what Node.js and code can do for you out of the box. As I said, it works almost magically in every environment, but obviously Docker can help a little bit more with microservices. And the first advantage it has is the immutable environment. Now, you'll be running maybe 50 services, 100 services in your production environment. You basically can't manually configure all of them, and you cannot make sure that every developer will run the same instances, the same versions of your services, and the same infrastructure, like the Node version, the NPM version, and the other tools that are necessary to run your application. You cannot make sure that everybody will run the same infrastructure. So what you do is you make use of Docker and Docker containers. They give you the immutable environment. So when you have the hash of the layer of the Docker image, then you give it out to your developers and you make sure everybody is running the same thing as if it's running in the production environment. So if you actually make use of Docker Swarm locally, even better, or like Kubernetes as well, even better, because then you can also give the list of your services to run. Hey, like here is the configuration to run 50 of these services and 20 different databases. You're good to go. With a single click, with a single shell command, you can actually bring up the whole production stack locally on your machine with very low cost. So, and it's guaranteed that it won't break. The hashes, the IDs of the layers are unique. So unless you change it, you make sure everybody is running the same thing. The second benefit is it actually gives you an overlay network. So your services can already find each other out by hostname, by DNS resolution. It gives you a network so that wherever your containers are, they can actually discover each other. So in that regard, that is a functionality that you can already use readily for your HTTP APIs, even if you don't use code. If you only have HTTP microservices, you can make sure to use the overlay network and benefit from all the scalability issues, scalability solutions it gives you, and the load balancing it gives you out of the box again. Another good thing is it auto restarts your app on failure. This is something we do with PM2, for example, or Node.js or any other process management system. But Docker already gives you auto restart either on failure or always, like whenever your application stops, even if it stops with a success code. Another product from Docker is Docker Swarm. How many of you are using Docker Swarm? You're using everything. That's perfect. Great. So Docker Swarm is an orchestration management tool. Who is using Kubernetes? That's great. These tools are very much like each other, and they give you some capabilities of, creating machines for you in an environment. You give your AWS keys, you give your DigitalOcean keys to them, and they create machines for you. They deploy your application. They do rolling upgrades to your application. And with a single command, you can scale up or down individual services or servers in your cloud platform. So when you give it your AWS key, you can say, all right, now give me 3 servers from this group with this tag name, and when the Black Friday is over, you can actually scale back down to 1 server. And these are all supported with single bash commands. It's really an amazing tool. And you can also use it locally, which means your developers can also run these on their own machines, and nobody is ever bothered with manual configuration anymore. And there's no refusal, or there's no blaming game anymore. Nobody can say, hey, it works on my machine. I don't care if it doesn't work on the production. That's your problem. This won't happen. If it works on the developer's machine, it will work everywhere. So it already helps with team communication. It also has, obviously, secrets management, and it runs as a cluster with a central node, a manager node. So you run 5 or 7 manager nodes of Docker Swarm, for example, or Kubernetes as well. And they are the management in your infrastructure. Then you have other servers that run your applications. But these nodes actually decide the scaling and the orchestration management commands and sends it out to the others and does the operations. So in that regard, this system is not decentralized. It is centralized, but at least it's highly available because you're running 5 different copies, and when you lose 2 of them, it will still work. Hopefully you put them into different availability zones in different data centers, so even if one data center is burning down, your application will not fail. Okay, Docker Cloud. Docker Cloud is another tool by Docker, another software as a service or platform as a service or infrastructure as a service, whatever you name it. It's basically Docker Swarm in the cloud, which is available with a nice user interface. So you can create your services, you can deploy them. You can actually have automated builds from your GitHub repository. So you give it a GitHub repository, it automatically builds it for you, it tests it for you. So if you're using Jenkins, you don't need it anymore. If you're using GitLab CI, you don't need it anymore. Docker Cloud can actually build your code for you, build your Docker images for you, and automatically deploy them. So you build it, you test it, and if the tests pass, hopefully you're writing good tests, then the deployment is also automatic. Because you're running 50 services, right? You cannot have centralized release management anymore. You have to let the teams release to production on their own schedule, and therefore you have to automate this. And Docker Cloud is a nice way of automating it. It also lets you bring machines or create machines from AWS, DigitalOcean, or other cloud platforms, and you can bring your own device, bring your own machine into your cloud environment. And yeah, the best part for me as a manager maybe is the Slack notifications. Out of the box, it supports Slack. Anybody using Slack here? Yay, that's great. Out of the box, it has Slack notification support, so any change in the system, if you want, are forwarded to a channel automatically. So you can basically see what your infrastructure is doing. If it's all green, that's perfect. If there are some red things, you'll see that it's automatically healing itself, correcting itself, And then sometimes you have to manually go in and destroy some servers, create some servers, but or maybe scale them up or down. But that's basically a great tool to streamline the delivery of microservices. So you just write your code, push to GitHub, and the rest is automatic. Everything happens automatically, right to production with zero configuration. Even if you're creating new services, even if you are bringing in new services, you don't deploy the rest of your application. So zero downtime, real zero downtime. Not like some requests are waiting for a new server to be up. It's zero downtime. It also gives you terminal access. So I told you in the beginning that SSH is bad for your health. So if you're SSHing into your servers, you should be looking for other ways. But if you need it, if you desperately need it, this thing gives direct access to individual containers running in your infrastructure. And maybe the best part for the enterprise is it scans your images, your Docker images, and whenever there's a vulnerability, it tells you. It says, hey, like, there's a severe vulnerability here in this image, and these services are affected, so, you know, maybe you want to update them. Maybe you want to change the image because there may be a new fix. So the security scans is a really nice feature for the enterprise because, you know, enterprise system administrators are like, no, I won't let anybody touch my servers. I won't let anybody install an upgrade. And this thing actually automates that part as well. All right, another demo time. This time, you can actually contribute from your browsers. I have deployed the previous e-commerce application to the cloud, to my server, and I would like to show it to you. It's admin.cote.js.org, enduser.cote.js.org, or monitoring.cote.js.org. And obviously, also the source code is available online. So if you ever like to try it out yourself on your machine or in your cloud environment, you can directly clone it. It has configuration for Docker Compose, Docker Swarm, Kubernetes, and locally running in your machine out of the box. So hopefully you just, you know, clone it, run it with a single command, and it will work. Let's see. All right, this is the monitor. Maybe we can start from here. So this is a preliminary version of the monitor that's built into code, where we see the services, individual services, the machines, the yellow ones are the machines, or the services. The blue ones are the individual services in those machines, and the green ones are code responders, requesters, or publishers and subscribers. So obviously there are more mechanisms in code to communicate with each other. And yeah, you see this is a live map, live updating map of services, and it shows how each service is connected to one another. Okay, so all right, you're already making a lot of purchases. That's great. Here, this is a live updating list on the admin interface. This is a single page application that works with WebSockets. Code also supports WebSockets out of the box, so it can directly communicate to the client without any middleman. And yeah, I'm just simply listening to updates to the users, and some people are like acting like it's Black Friday, making crazy purchases. 4 of them, 4 of the same thing. That's great. And you can also create, all right, new products. Please don't delete my products. This happens all the time in the demos. People love to delete the products. Please don't delete all of them. Or you can, because it's fun, right? It's fun to hack the system. So you can add a new product, and maybe I lost my internet. Can anybody create a product for me from the admin interface? Yeah. I guess we're all trying to shop like crazy on the system right now, and the web, the Wi-Fi maybe. Yeah. So you see on the front end automatically, there's a very nice product for $100 if you like, but nobody can buy it because the default wallet you have is $30. So on every refresh you have A new user created for you, 40, 42. Who is 41? You must be here. 43? Oh, 41, yes. So 43 I'm again. But anyway, so this is basically what code can do for you. And I have only a couple of minutes, but if you're interested, I could actually show you the code of how this thing works as I demonstrated. Are you interested in it? Maybe a little? Okay, that was a little bit awkward. Thank you. Okay. The most beautiful part are the front end. It's an AngularJS application, really old, 1.5, because back then we didn't have 1.6. But you see we are making use of WebSockets, connecting directly to the user and purchase namespaces. And again, no ports, nothing. And it's basically like about 100 lines. Whenever I want to create something, I want to create a product, I'm just posting to the product endpoint, all right? And whenever I have a result, I list the products again. So it's not really live updating on the admin, but I do a fetch again. So what happens when I create a product? Here's the Express implementation. So whenever I'm posting something, I'm forwarding it to the product requester, which will communicate with the product responder, and it will create something. And in the end, I send it back to the end user. Product service, on the other hand, has a responder here and responds to create messages. Very simple, as I've already shown you. Just does model.create, and additionally, it updates the product, which says, hey, product publisher, there has been an update to the products, to the catalog, so fetch all the products and publish it again to the users, to the outer world. And the client, the end user, is actually listening to those updates on the front end. So you publish an event from the back end, there is no middleman involved. It's directly sent to all the customers that you have who are already connected at that point in time. So yeah, this is basically as easy as you see here. This is no magic. This is all simple JavaScript. It's no magic like Meteor or any other crazy tool. It's just WebSockets and some intelligent implementation. But let's go back. And all right, that is the end of my talk today. Thank you.